Good afternoon, dear students. Today I am going to start a new topic, new Unit 6, Gaseous State. The things that surround us is known as matter, and we are classifying the matter into three types. First one solid, second liquid, third gas. So you know that solid, the character of solid, it contains definite volume and definite shape. Okay, and liquid, they contain definite volume but indefinite shape. Okay, so when whatever vessel we take to pour into the water or any other liquid, that liquid is adopting the shape of that vessel. Okay, so that is the character of liquid, indefinite shape of liquid. And another particle, the third particle of matter, is known as gas. So generally gas, what is gas? The molecules which are always in motion, so that particles are known as gas particles. So they are in always in always in motion. So moving particles. Moving particles. How they are moving? Freely moving particles, that is gas. And did they have a definite volume or definite shape? No, they don't have definite volume and definite shape. Okay, so indefinite volume and shape. So they don't have volume and shape, definite volume and shape. They have indefinite volume and shape. Okay. So gaseous particles are always moving. They are always moving particles. Then take our environment. What are the matters you can see? Some of the material or the matter is solid and some are liquids, and the room consists of some atmosphere, the gas particles. So because of that gas particles, we survive in this earth. Okay, so we can't live without air, without oxygen, without breathing. So but we can live without food and water in a day or twice a day. Oh, okay, couple of days we can live, but without air we can't live for 2 minutes. At least 2 minutes we can't live. So this is the importance of gas particles in our atmosphere. So what are the gas particles is useful for our body? For inhale, oxygen is an important gaseous particle to survive human being into the in this earth. Okay, so you know that respiration system, inhale oxygen and exhale carbon dioxide. So both are in the gaseous state. So for example, we take that atmosphere, which is consist of many elements. They are present in the gaseous state. So the gaseous state is an important state, is playing the important role. Gaseous state is playing the important role in the life of human being and also for the life of non-living things. The air which is present in the atmosphere contain different gaseous state, different gas particles. Although their chemical behavior is different for each other because of the composition of each element is present in the gaseous state. Okay, so take the atmosphere is surrounded by an the earth is surrounded by an atmosphere. We can take the composition, the air composition. Air composition. So what are the elements are present in the atmosphere? oxygen, nitrogen, carbon dioxide, chlorine, fluorine, sulfur, ozone, neon, krypton, argon. Okay, so these all the gaseous particles which is present in our atmosphere. So from the atmosphere we can understand some elements are present in the form of molecules like nitrogen. Nitrogen is present in the form of molecule. N2 is it's a molecule of nitrogen, and O2, this is also molecule of a molecule of oxygen. Then F2, this is molecule of fluorine. Then Cl2, molecule of chlorine. So some of the elements are present in the air in the molecular form. So these are dimolecules, and one element is present in the atmosphere. It is a tri-molecule. So tri-molecule of oxygen is ozone. So three oxygen molecule bonded together. So that compound is known as ozone. This is also present in our atmosphere. So these all the elements are present in our atmosphere and also at a room temperature. In the condition room temperature, it's present in our atmosphere as dimolecules and also trimolecule. And the next case, some noble gas also present in our atmosphere. So what are the noble gases present in our atmosphere? Helium, neon, argon, krypton and xenon. Okay, so these all the noble gases are present in our atmosphere. But they are monoatomic compounds. So these noble gases are present in our atmosphere in the form of monoatomic, and this nitrogen, oxygen, fluorine, chlorine are present in diatomic, and one of the another atomic molecule is present in our atmosphere is trimolecular compound, that is oxygen, that is ozone. And also present some compounds like carbon monoxide, carbon dioxide, carbon monoxide, carbon dioxide and nitrogen dioxide, then nitric acid, nitric oxide. So these all the compounds are also present in the atmosphere. From this we can easily understand the role of gas or the role of atmosphere in our daily life for the survival of human being. Now, from the physical properties or from the character of gas, some scientists have formed some law about this gas particles. That means the gaseous state or the gas law, we can generally say that is the gas law. Gas laws. Under this gas laws, we have four type of laws: Boyle, Charles, Avogadro and Gaseous. Boyle's law. So this Boyle's law relating pressure and volume. So we only scientists explain the gaseous law by the physical properties of the gas particles. So the physical properties like pressure, volume. Okay, so this Boyle's law is explaining the relation between pressure and volume. Next law is Charles' law. Charles' law is explaining here volume and temperature. So the relationship between volume and temperature. Relation between volume and temperature. Next law is Gay-Lussac's law. Gay-Lussac's law. So which is explaining the relation between pressure and temperature. Pressure and temperature. Okay, so first one, Boyle's law is explaining pressure, volume. Then Charles' law is explaining volume and temperature. Then Gay-Lussac's law is explaining pressure and temperature. Okay, and the last one, last law of this gas law is Avogadro hypothesis. This is one definition. Avogadro's hypothesis. Avogadro hypothesis. So we can go to the introduction of this the gas laws. Gas law is generally explaining the physical property of gas particles. Before studying these four laws, we have to understand the pressure, volume and temperature physical properties. Pressure equal to force divided by area. So what is the unit of force? Newton or kilogram meter second power minus 2. This is unit of force. Then what is the unit of area? Meter square is the unit of area. So what is the formula of pressure? Force applied on area is pressure. And the SI unit of pressure is SI unit. SI unit of pressure is Pascal. Or we can define this as Pascal is 1 Newton per square meter. It's Newton meter power minus 2. We have some other relations also. Some unit for pressure. This is a table which is explaining units of pressure. First one, unit of pressure Pascal. Pascal symbol PA, and 1 PA is equal to 1 Newton meter power minus 2. Atmosphere is symbol of atmosphere is ATM, and 1 ATM, 1 atmosphere or ATM is equal to 10,325 Pascal. Okay. The next unit, millimeter of mercury, mmHg. Hg means mercury, and 1 mmH is equal to Hg is equal to 133.322 Pascal. 1 bar. We are also mentioning this bar is a bar. Okay, symbol also it is bar. So 1 bar is equal to 10 power 5 Pascal. Torr, 1 torr is equal to 133.322 Pascal. So these two values are important. Okay. Then pounds per square inch, PSI, pounds per square inch, PSI. 1 PSI equal to 6894.76 Pascal. So these are the units of pressure. First law is Boyle's law of the gas laws, from the gas law. Robert Boyle is explaining the Boyle's law, and he is relating pressure and volume. So what is the relation between volume and pressure in the gaseous particles? Okay, so for understanding the relation between pressure and volume, he took some apparatus like this and labeling here A and B. So in this apparatus, one end is closed end and another end is the open end. So it contains only one open end and one closed end. So this is one tube, which is closed in one end and open in the another end. So this open is using to fill some liquid or anything into this tube. Now you can consider this tube. Is this empty tube? No, it contains some gas particles. We can't see that gas particles, but it contains gas particles into that tube. Okay, so now we are going to measure the pressure with the volume, relation of gas. Now take this first tube, take this tube and fill this tube with some amount of mercury. Okay, filling this with some amount of mercury. So now if you fill any kind of tube, then that liquid will be go down to the lower part to that tube. Okay. Okay. So mercury is filled in this part. Mercury is filled in this part. We pour some amount of mercury into it. Now you can consider, now you can see the place which is in the left side of this tube. That means in the closed side of this tube. We already know that this tube contains, it's not an empty tube, it also contains some gas particles. Okay, so that gas particles which is present in this tube, when you pour the mercury into this tube, that mercury or the volume of that liquid particle is removing or replacing this air particle is present in this tube. Okay, so that all the air particles are moved by this amount of mercury, and it went into this side. Okay, this closed side, it not escaped from this side because it is a closed tube. Okay, so it is not escaped from this side. Now you can see this gap. You can't see the gas is there, gas is filling here, but we know that the amount of gas particles is present in this tube. Now it is in this place. Okay, only occupying this volume. Now add some more amount of mercury with that mercury. Okay, so this is first step, first one. Okay, then again filling this tube with some more amount of mercury. Some more amount of mercury. See this one? You can't say this is a vacant place because this place contains some amount of gaseous particles. Then again increasing the level of mercury in this tube. Increase the level of mercury in this tube. We can label this as a C. Now the gas particles which is present in this tube, it's occupied only this volume of that tube. Okay, so there's no way to escape from that tube, so it is filled in this place and they exit or they apply some pressure into the liquid, that means into mercury. And here also we have some pressure from the outside gas particles, but here in this side, this liquid or this mercury experience some pressure from the gases which is filled in this place. Okay, now compare this three figure. First figure, in the initial stage, the pressure which is exerted by the gas, it is equal to 1 atmosphere, because the level of mercury is not different, so they are same, so the different height of mercury is 0. Okay, so you can see the level of mercury, both are same in this figure, but you can come to the next level to adding the excess amount or some more amount of mercury into the same tube, then the level is different. So the level of mercury from one side to the another side, it is different. Okay, height of mercury is different. So this height is 760 mm. So now you can identify the pressure which is exerted by this gas. It's 2 atmospheric pressure. Why it's become 2 atmospheric pressure? Because here it is 1 atmospheric pressure, because the volume is more, the volume occupied by the gas in this tube or in this side is more, so there is no difference between the height of mercury. Because of that, the atmospheric pressure of this gas or the pressure exerted on this mercury is 1 atmospheric pressure. But you can see the second figure, the liquid which is filled in this tube, it's exerting some pressure on that atmospheric gas. So now this the volume occupied by this atomic molecules or the gaseous particles, now they reduce the volume. So the volume is reduced by V by 2. That means volume, this is full volume, and this volume is reduced by 2. That means it is reduced into half of the volume. So because of that, the height also it is increased between one side to the another side. The difference between the height, mercury height 760 millimeters. So the atmospheric pressure is become the pressure exerted on the gas by the gas on liquid or the mercury is 2 atmospheric pressure. And in the third case, it is increasing because the volume is reduced into V by 3. So the difference between the mercury level, it is increasing. So the atmospheric pressure is exerted more here than these two tubes. So this is the relation between volume and pressure exerted by the atmospheric gas or any gaseous particles. So he concluded that a given temperature of the volume is occupied by a fixed mass of a gas. It is inversely proportional to its pressure. What he is explained, Boyle? He explained volume is inversely proportional to pressure. So in the mathematical term, you can write volume is inversely proportional to pressure. So T is a temperature and N is number of mole. We can V is volume and P is pressure. So to removing this proportionality, we add here one constant is proportionality constant. So V is equal to K. The proportionality constant K is proportionality constant. Proportionality constant. So you can write proportionality constant into 1 by P. From that we can conclude P is moving to the side, so PV is equal to K. But when they ask the Boyle's definition, you have to write the definition of Boyle and the equation, this equation. So Boyle's law is applicable for the all gases, but it's not depending upon the chemical entities is present in that. M is mass and D1, D2 are density of the gas. P is pressure and P2 is pressure 2. So you can we can derive the equation like P1 divided by D1 equal to P2 divided by D2. This is the relation between pressure and density by Boyle's law. So we can say from the relation between pressure and density, pressure is density is directly proportional with pressure. So this much only today's class. The Boyle's read out Boyle's law fully, understand the concept and study the explanation of Boyle's law, experiment part and the equation part be inversely proportional with P, and the explanation PV is equal to K, and the graphical representation of Boyle's law and the consequences, the relation between P and D, that means pressure and density. Okay, worked it out today. Okay, thank you students.